This lesson is part of a series of training videos where we will look at a specific product in a specific installation, comparing our installation instructions and good practice with actual conditions on a job site. The primary goal is to help you become more familiar with our products, enabling you to tell if they've been installed correctly and if they're doing what they're supposed to be doing. Along the way, we'll also discuss what's important for when we need to determine if something is close enough, what's dangerous for when we need to bring something to the contractor's immediate attention, and why our products are used the way they're used. These videos will assume you're already somewhat familiar with the products being discussed. If you haven't already done so, please take some time to watch our other product training videos that go into detail on our various products, features, and components. Vibro-Acoustics creates noise control solutions for the HVAC industry, addressing both airborne and structure-borne transmission paths. Our vibration isolation products help mitigate equipment vibrations that could cause noise problems in buildings. In this lesson, we will look at SCSR isolators installed on a cooling tower. In mid-2015, Vibro-Acoustics secured a vibration isolation order for a project in downtown Toronto called the Axiom Condominiums with multiple pieces of equipment and piping. The mechanical penthouse of the East Tower included various pieces of equipment. We've already looked at the chiller in another lesson, and this lesson will look at the cooling tower, located here in this area well. As required by the project documents and as recommended by the acoustical consultant, this cooling tower is supported by restrained spring isolators, specifically 2-inch deflection SCSR isolators, complete with neoprene pads under the base plates. They were selected for each side of the equipment based on the weight shown in the cooling tower submittal, which is about 10,330 pounds. As an interesting side note, originally CSR isolators had been quoted and selected, but were then replaced with SCSR isolators due to their inherent higher strength for resisting lateral loads from wind and seismic forces. This project was exempt from seismic requirements, so it was only wind loads that were of concern. This is the datasheet and installation instructions we provided on this project for this cooling tower. Note that the most recent versions of these datasheets and installation instructions are available on our website. They are often subject to changes and improvements, so always refer to the latest for the most up-to-date information. Let's take a closer look at the datasheet and installation instructions for this isolator and focus on some key things we'll want to look for when we visit the job site. In a previous training video, we went over the various parts of an SCSR isolator, explaining their uses and functions. This graphic here is meant to help familiarize the contractor with the various components, their names and locations, which are referred to in the notes and instructions. It shows overall dimensions of the product as well as dimensions of holes for attaching the isolator to structure and to the equipment if they choose to bolt rather than weld. It also shows the expected working clearance between the equipment support plate and the rubber washer on the hold-down plate, 1/4 inch. This will be something we'll want to look for at the job site. Also on the datasheet are some notes that need to be considered. They provide descriptions of the materials used and the functions and purpose of different components. A few of these are things we'll want to look for at the job site. This note says top plate and restraining bolts are designed to be out of contact with housing during normal operation. So combined with the working clearance shown in the graphic above, we'll want to make sure those components are not in contact. Here it says reinforced neoprene elements, snubbers, are incorporated to minimize short-circuiting of restraining bolts. We'll want to take a look at those and see that they're doing their job. If less than 80% of the top plate is covered by the supported equipment, use an additional plate, same thickness as the isolator's equipment support plate, on top of the isolator. This note is clarified on the installation instructions page, which we'll look at next. But before we leave this page, one more very important thing is the plan view of mount locations. This graphic shows which isolator goes where on the equipment. With induced draft cooling towers like this one, it is common to see the center of gravity in the geometric middle, so the isolators will be the same in the corners, shown here in positions 1, 2, 3, and 4. When the tower is heavy, or as in this case there are specific support points, it is common to see an additional pair of isolators in the middle, positions 5 and 6. Here we can see that the middle two isolators are SCSR 2A 3200s, and the corners are 1600s. According to the table above, when we check the spring colors at the job site, we should see black outer springs with red inner springs in the middle isolators and green outer springs and black inner springs in the corner isolators. Here is the installation instruction page. After a warning about proper handling of the isolators, the next instruction on the installation instructions page says to properly locate each isolator using the model and spring colors as identification. The instructions then go on to explain the process for installing the isolators and then the equipment onto those isolators. We won't cover that part in detail here, however, there is one instruction here that is important with cooling towers, and that is to center the isolator under the equipment load or under the web of a cooling tower base, which we'll cover in another video. The instructions here are perhaps a little out of order. It is important to secure the isolators to structure first before lowering the equipment on top of their top plates, especially if securing to concrete as discussed in Note 4. This project has the isolators mounted on steel, but in other projects with concrete, the anchor bolts need to be installed with adequate depth and edge distance before the isolators are placed. Though not stated here, it is common and standard good practice to center the isolator above the web of a support steel dunnage beam, then bolt or weld to the beam flange. At the job site, we'll need to make sure the isolators are adequately secured to structure. Instruction 5 says to attach the equipment to the support plate, for example with welds or bolts. The datasheet gives the size and location of bolt holes in the top plate should they choose to bolt, and the graphic here says that weld is specified on calculation sheet. However, this project was an isolation-only order, and no calculations were done. For any outdoor equipment, it is imperative that they be adequately attached to withstand code-mandated wind loads. We'll definitely want to make sure that the equipment is either bolted or welded to the top plate. This image here better explains the 80% rule, where an extra top plate is required to add additional stiffness and prevent sagging during installation. Though not explicitly stated here, it would be expected that the equipment or steel beam would be welded to the extra top plate, and it in turn would be welded to the isolator top plate. The next step shows that the contractor needs to move the hold-down nut to touch the head of the limit bolt. This will allow the equipment to float. This step is often missed, so we'll want to check that this has been done. This step shows the contractor how to adjust the isolators to transfer load to the springs. Note the adjustment pattern plan view on the right, which helps ensure the load is evenly distributed among the different isolators. A common site problem is springs that have been over-adjusted because this pattern and process was not followed properly. This instruction says to remove the spacers once the equipment is floating on the springs. Another common issue on job sites is that the spacers have not been removed, often because the springs were never adjusted. We'll want to see that the isolators are adjusted and the spacers removed. Now that we've looked at the submittal datasheet and installation instructions, we're ready to go look at the installation on the job site. Here again is the cooling tower at the top of the east tower of the Axiom condominiums. Before we get started with our walk around, let me make my first observation. The tower is sitting directly on the isolators instead of on a steel support base first. This could be a dangerous issue if the tower had not been designed to be supported at specific points like this. When I checked the cooling tower submittal, which had been reviewed and approved by the mechanical engineer of record, the manufacturer showed the need for beam supports on the two short sides of the tower. So hopefully the contractor didn't just assume it would be okay, and either the tower was already able to be supported at the 6 points, but the submittal didn't show it, or the manufacturer made a change to allow this. Otherwise, it is very possible that the tower casing could have failed when filled with water. Let's go ahead now and take a walk around to look at the isolators. I'm going to play the video straight through, pausing at each isolator to check a few things while providing some commentary. Then we'll go back and look more closely at one of the isolators to discuss some details. This is the air inlet side of the cooling tower, and as explained earlier, it does not sit on a steel support base but instead sits directly on the isolators, labeled here to correspond with the locations shown on the datasheet. As we approach the tower, everything appears to be stationary, straight, and level, so we can inspect the isolator safely. That's location 1 over there, but we'll look at location 2 first. Immediately, I notice that the working clearance is less than it's supposed to be. Fortunately, we can still see daylight between the top plate and the hold-down plate, and that the upper reinforced rubber washer of the all-directional snubber is there. There's a little more space between the lower snubber washer and the hold-down plate than I'd prefer, but the washers are in place and free to move. The hold-down nut has been lowered down to where it's supposed to be and is securely in place. The NSN pad under the isolator looks okay, and the isolator appears to be bolted down. Here is one of the spacers which are in place during shipment and initial installation. If the tower had been brought up to operating weight before the isolators were adjusted, this spacer would still be able to fit between the top plate and the hold-down plate. As expected for an SCSR 2A 1600, the outer spring is green and the inner spring is black. The springs have been adjusted and the spring compression cup is not in contact with the side stanchions. Next is location 6, and as expected, the outer spring is black and the inner spring is red. Checking the bolts, I find that one of them is loose. It appears the contractor chose to cut costs and used cut pieces of threaded rod with nuts instead of proper bolts, washers, and nuts. The hold-down bolts appear okay, and there's plenty of gap between the top plate and hold-down plate on both sides, though perhaps just slightly more than necessary. The neoprene pad appears okay here too. At location 4, we find another SCSR 2A 1600 with a green outer spring and black inner spring. There's plenty of space between the top plate and hold-down plate, but the upper rubber snubber washer appears a little damaged, possibly from the spacer being placed between it and the hold-down plate during initial installation. The lower part of the snubber is loose and not in contact with the side stanchion. Here is one of the spacers. We can see how much extra room there is in the gap, probably as a result of the isolators being adjusted before the tower was brought up to its operating weight. The spacer should have been positioned like this, next to instead of on the rubber washer. These makeshift bolts appear to be adequately tightened on this isolator, so we know it's attached to structure. But what about the attachment to the equipment? Here we see a fillet weld between the tower and the isolator top plate edge, and around on the long side we see 3 more welds, all of which have been spray painted for corrosion protection. Moving to the far corner at location 3, we find the isolator secured to the steel support. The spring has been adjusted, and I can feel vibrations in the spring coils. There's more of a gap than necessary under the top plate. Although the snubber washer appears damaged, it's still able to do its job of minimizing metal-to-metal contact. The tower is attached to the isolator with welds that look okay. The hold-down nut and washer are free to move, and therefore not short-circuiting the isolation. Here at location 5, we find another loose makeshift bolt. These need to be tightened. The rest of the isolator appears okay. The equipment is floating, the spring has been adjusted, and the hold-down bolts look mostly okay. The undersend pad looks okay too, but these other makeshift bolts are also loose, which means they probably were not tightened after the tower was filled with water. And finally, we come to location 1, where we see the most compressed spring of the group, and the only location where the top plate is sitting on the side stanchions. This is evidence of installation instructions not being adequately followed. Note that the spacers have been removed, which means that the isolator was adjusted prior to the tower being filled with water. Though not impossible, this is difficult to fix. So what do you think? Did you see anything we need to have the contractor fix or correct? Or was it close enough? Was there anything dangerous? Did it appear to you to be working? Let's talk about the isolator at location 5 and consider the items mentioned when we reviewed the datasheet and installation instructions. Is it the right isolator in the right place? Yes. This is an SCSR 2A 3200. This and all other isolators are correctly located as shown on the datasheet. Have the spacers been removed and is the equipment floating? Yes, at this and most locations, the equipment is being supported by the spring and the top plate is not touching the side stanchions. However, as we saw at location 1, that top plate is sitting on the upper snubber rubber washers on the side stanchions and is not floating completely on the spring. This could be a problem that may create a vibration isolation short circuit path where the vibrations from the equipment go through the side stanchions instead of into the spring. It was difficult to tell for sure, but I think the snubber washers were doing their job to prevent metal-to-metal contact, which could have caused further structure-borne noise problems. So the answer to this question goes in the mostly okay category. Items in this category typically only need to be addressed if they create additional problems or if there is evidence of structure-borne noise, or if there was a need to certify the installation. If that were the case, we would need to mark this as something that would need to be corrected. Correcting this requires the contractor to lower the tower back onto the spacers where they can be reinserted and then proceeding to put weight on the springs in the manner and method described on the installation instructions page. Is the working clearance 1/4 inch? Well, here at location 5 it's okay, but we found that locations 1 and 2 have less clearance than shown on the datasheet and locations 3 and 4 have more. As explained in the previous question, this one goes in the mostly okay category since most of the isolators have the clearance, but the contractor may need to readjust the springs if any noise problems arise. Are the springs adjusted? Yes, we saw that all the springs had been compressed. The unloaded free height of these particular springs is 5.5 inches. We can tell these have been adjusted since they are now shorter. In some cases, an acoustical consultant will want to measure this static deflection to check for compliance with a specification. The greater the deflection, the more frequencies will be isolated. It is also important to note that the springs are not flat or fully compressed. If the spring coils were touching each other, that would mean that there was too much weight placed on the isolator. The spring at location 1 was the most compressed, but still working. Overcompressed springs can often be fixed by readjusting the isolators around the equipment or replacing the overcompressed springs with stronger ones. Are the snubbers in place and are hold-down bolts properly set? The snubbers are in place and the hold-down nuts are touching the hold-down bolt heads for this and all isolators, but we saw some damaged rubber washers and in some cases, though I didn't mention it during the walk-around, I could see the threads of the hold-down bolt where they should have been covered up by a red reinforced rubber hose. The damaged washers were still in place and not cut all the way through, so can be considered okay. The rubber hoses may have been pushed out of position during installation, and it would be better if they could be pushed back into place, since they are needed to help prevent metal-to-metal contact during seismic and significant wind events. However, this particular tower has no seismic restraint requirements and is well protected in a full enclosure well, so the position of those rubber hoses is much less important, and so this question can be answered with a yes, since it's close enough. Is the equipment supporting less than 80% of the top plate? Well, it's hard to say for sure. I didn't measure it. But it doesn't matter in this case, since the equipment load is primarily along the long axis center of the top plate. The missing description in the installation instructions extra top plate requirement is that it really only applies when the load is perpendicular to the plate or if the equipment foot is smaller than the opening or distance between the side stanchions. In other situations where the equipment support is smaller than 80% of the top plate, as long as the top plate is not deformed and nothing else damaged, then it would be okay. There could be a problem if too heavy a load is placed on too small an area on the top plate, which could cause it to deform during installation before the springs are adjusted. This could lead to the hold-down bolts being angled and creating short circuits with the hold-down plates. Is the equipment connected to the isolator? Yes. There are multiple welds at each isolator that are at least 2 inches long and spaced out from end to end. If calculations had been done, we would have checked that the welds matched the submittal description. Is the isolator connected to structure? Yes. Though no calculations were done, they definitely had the right idea. Since the base plate is wider than the supporting beam, the contractor added another plate matching the isolator's base plate size as well as bolt hole locations under each isolator. This provides full support for the NSN pad under the isolator as well. In most applications, the middle two holes on either end are used to attach the SCSR isolator housing to steel structure, and the base plate overhangs the beam on either side. The general rule of thumb is that the beam flange width needs to be at least as wide as the spring, if not the side stanchions. In this case, they used the 6 outer holes typically used for attaching to concrete to attach to the matching support plate, which in turn was welded to the support beam. The contractor used pieces of threaded rod and 2 nuts to secure, which, as we saw, were not all tight, making this mostly okay. Since this is an outdoor piece of equipment that may see wind loads, we'll need to tell the contractor to check and tighten all of the makeshift bolts. So that wraps it up. My final conclusion on this site visit is that the isolators have been installed close enough to our installation requirements to be okay, but should they experience any vibration or noise problems in the spaces below the cooling tower, or if they need an installation certification, they will need to adjust the isolator at location 1 and ensure the top plate is floating and out of contact with the stanchions. In this lesson, we've looked closely at the datasheet and installation instructions for an SCSR isolator in the context of performing a site inspection where SCSR isolators were used to support a cooling tower. We discussed various items to look for during an inspection and assessed whether the product was installed in a manner that would enable it to do its job. I hope through this lesson you've become more familiar with the SCSR isolator and its use.